Stars are formed through a complex and fascinating process known as stellar formation. This process occurs within vast clouds of gas and dust called nebulae, which are found throughout galaxies in space. The most common type of nebula where stars form is called a molecular cloud. Initial conditions. The process of star formation begins when a region within a molecular cloud becomes dense enough to collapse under its own gravity. Various factors, such as shock waves from nearby supernovae or the gravitational influence of nearby stars, can trigger the collapse of a molecular cloud. Gravitational collapse. As the molecular cloud contracts, it fragments into smaller clumps or cores. These cores continue to collapse under gravity, and the matter within them becomes denser and hotter. Protostar formation. As the core collapses, it forms a protostar, which is a baby star still surrounded by a thick envelope of gas and dust. At this stage, the protostar is not yet generating its own energy through nuclear fusion. Accretion disk. As material continues to fall onto the protostar, it forms an accretion disk around the central protostar. This disk is composed of gas and dust, and it is from this disk that planets and other celestial bodies may eventually form. Nuclear fusion ignition. As the temperature and pressure in the core of the protostar increase, nuclear fusion reactions begin. Hydrogen atoms in the core fuse together to form helium, releasing an enormous amount of energy in the form of light and heat. This marks the point at which the protostar becomes a main sequence star. Main sequence. Once nuclear fusion ignites, the star enters the main sequence phase, during which it will spend the majority of its life. The star achieves a stable equilibrium between the outward pressure from nuclear fusion and the inward gravitational force. Balance of forces. Throughout its main sequence phase, the star remains stable due to the balance between the force of gravity trying to compress the star and the energy released from nuclear fusion pushing outward. Life cycle. The length of time a star spends on the main sequence depends on its mass. Massive stars burn through their fuel quickly and have relatively short main sequence lifetimes, while smaller stars, like our Sun, have longer main sequence lifetimes. Later stages. Eventually, a star will exhaust its nuclear fuel in the core. The fate of the star depends on its mass. Smaller stars become red giants, shed their outer layers, and eventually become white dwarfs. Larger stars may go on to become supernovae, neutron stars, or even black holes. In conclusion, stars are formed from the gravitational collapse of dense regions within molecular clouds. This process leads to the creation of protostars, which eventually become main sequence stars and undergo various stages of evolution based on their mass. The life cycle of stars is a fundamental process that shapes the structure and dynamics of galaxies throughout the universe.